Now let's look at how you use sine, cosine and tangent to find an unknown angle when you know two sides on the triangle that you're dealing with. So first of all, we're going to label the sides we're interested in. If it's this angle we're looking at, then this is the opposite. And of course, this side is opposite the right angle. So this is the hypotenuse. So we've got the hypotenuse here and the opposite here. If we're dealing with opposite and hypotenuse, we need the SO triangle. So sine of the angle is opposite over hypotenuse. In this case, sine of R is opposite is 2.1 divided by hypotenuse is 5.2. Now you can leave it as a fraction, that's absolutely fine, or you can write it as a decimal. But if you want to write it as a decimal, make sure you use extra decimal places. So at least 4 decimal places, preferably 5. Now we need to find the angle that has a sine of 0.40385. In other words, what does this angle have to be in order for this side length divided by this side length to always be 0.40385? And to do that, you need to use the inverse sine function on your calculator. If you look above the sine button, you'll see little letters saying sine to the -1. That's the inverse sine function. So you press the shift button and then the sine button. So R is inverse sine, shift and sine on your calculator. Put 0.40385 in your brackets and it gives you 23.8 degrees. If it's a question involving cos or tan, so if you're dealing with adjacent hypotenuse for cos or opposite and adjacent for tan, you use inverse cos or inverse tan in the same way. Right, so here are some for you to have a go at. Pause the video, see if you can work out your answers, and then press play when you're ready to go through them. First one then. First thing we do is label the sides. This is the hypotenuse, we don't want that. 5 is the opposite, and 4 is the adjacent. If we're dealing with opposite and adjacent, then it's the tan triangle. So tan of the angle A is opposite over adjacent, that's 5/4, which you can leave as 5/4, or you can write as 1.25. We need to untan it, get rid of the tan bit and just get back to the angle that has that tan. So we find the inverse tan of 5/4, or the inverse tan of 1.25, and that gives you 51.3 degrees. Second one, the 12 is the hypotenuse, the 8.5 is the adjacent. Since we're dealing with adjacent and hypotenuse, it's the cos triangle. So cos of B is the adjacent, which is 8.5, over the hypotenuse, which is 12, and that gives you 0.70833. We need to get rid of the cos bit, so we need to inverse cos it. So the angle that has 0.70833 as its cosine is inverse cos of 0.70833, and that gives you B equals 44.9 degrees. And then for the third one, label the sides again. There's your right angle, so the 13 is the hypotenuse, and the 11 is opposite to the angle we're interested in. So it's a sine triangle question. Sine of C is the opposite, 11 over the hypotenuse, 13, which if you want to give it as a decimal is 0.84615. So C is the inverse sine of that, or the inverse sine of 11/13. You don't have to give it as a decimal, remember. In fact, if you keep it as a fraction, then you avoid any rounding errors. And C comes out to be 57.8 degrees.